Okay, the impact of science is magnified when it is shared and when communities feel connected to the outcomes of that work. When you engage in discussions like this, when you ask questions, share your insights, or champion health initiatives in your own lives, you are part of that impact. Tonight's discussion highlights the intentional shift in how we approach health at the University of Waterloo. We've made a conscientious decision to bring health to the forefront through the Bench to Bedside series because we recognize its profound importance. But our commitment goes deeper than that dialogue. I hope tonight's discussion inspires you to see yourself as part of this overall group effort towards a healthier, more vibrant community partnership. Whether through your feedback, your support, or simply your presence here this evening, you help make our work stronger and more impactful. Science doesn't exist in a vacuum. It thrives on collaboration, dialogue, and on connection. Thank you for being part of this important conversation and for contributing to the collective effort to build healthier, more resilient communities. Together, we can ensure that discoveries made here at Waterloo make a real difference out there in the real world. And of course, if you're inspired to make an even greater impact, there are many meaningful ways to directly support the future of health, research, and innovation. Whether through contributions to undergraduate scholarship programs like Impact Biology, or transformative initiatives such as Waterloo's Eye Institute. Your investment will help us realize our mission in translating health-related research into real-world solutions. Our advancement team will be available after the event tonight to answer any of your questions and assist in directing to support to one of our funds dedicated to empowering students and advancing discoveries in this field. But before we begin, it's important to acknowledge that the University of Waterloo acknowledges that much of our work takes place on the traditional territories of the neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land granted to the Six Nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campus through research, learning, teaching, and community building, and is coordinated within the Office of Indigenous Relations. I'd also like tonight to extend a heartfelt thank you to our Waterloo panelists who are sitting, and they'll be up here shortly, for sharing their time and expertise with us tonight, as well as on the organizers for bringing us together for such an important conversation around health, research, and innovation. Tonight, I'm pleased to introduce you to our panelists. First, we have Dr. Dale Martin, a researcher in our Department of Biology who is at the forefront of cutting-edge brain research, unlocking the complex mysteries of neurodegenerative diseases to pave the way for groundbreaking future therapies. We have Dr. Travis Craddock, a new faculty member in the Department of Biology and Canadian Research Chair in Quantum Biology, who studies biological processes and biochemistry of the brain at the quantum level. We also have Dr. Ben Thompson, a faculty member from the School of Optometry and Vision Science and a University Research Chair who is revolutionizing vision care around the world. So now I'd like to invite Dr. Thompson to the front to introduce you to a special member of our greater community, Barbara Salzberg-Matthews. She'll be our fourth panelist tonight, and I think will bring a unique and powerful perspective to our discussion. Dr. Thompson.
Thank you, Paul, and it's fantastic to be here this evening and to be part of today's event. So to begin our panel discussion, I'd first of all like to introduce our keynote speaker for this evening, Barbara Salzberg-Matthews. Barbara has been creating art since she was a child. She studied mime in Paris, France, and had a touring mime company. Barbara graduated with honours from the Ontario College of Art and earned her M.Ed from the Ontario Institute for Studies in Education and taught visual and dramatic arts in high schools for over 25 years. A lifelong advocate for the arts and an inspiring force in the fight against Parkinson's, she has dedicated her life to enriching her community through creativity and compassion. After being diagnosed with Parkinson's disease in 2020, Barbara transformed a personal challenge into a platform for helping others. She created the innovative Mime Over Mind program, blending her background in mime with therapeutic techniques to support those living with Parkinson's. The program has gained international recognition and is now part of the University of Guelph's new Bachelor of Creative Arts, Health and Wellness degree. Barbara is also on the Canadian Open Parkinson Network's Parkinson Community Advisors Committee. In 2023, Barbara's tweet of a video of her dancing went viral within the global Parkinson's community, evolving into a PD Avengers awareness campaign called Dopamine Dance Against PD. One of her latest initiatives is the free book, What Parkinson's Feels Like. With the help of Parkinson Europe, Barbara collected descriptions of what Parkinson's feels like from people living with the condition and transformed these into a new book of illustrations. She lives with her husband in Guelph, where she does volunteer work and continues to make art. Barbara, welcome.
Yeah, Ken? You're good? Hey, all right. Well, thank you for having me here today. I'm going to share with you my experiences as a person with Parkinson's disease. A few years ago, I was living. I was retired. Our 2 children were launched. My husband / boy all over the world with me. And I went back to my first love. And that was, I started my work and getting recognized as a professional painter. And then something was going on with my hand here. It started wanting to play piano, and there was no piano around. So eventually, I got diagnosed with Parkinson's disease on January 20th, 2020. And just show you what it's before after artwork. Now, if you can go back to that first slide, you'll see full old building. That's downtown Guelph, Kelly Block and the Petrie building. What I used to do as a painter before Parkinson's was hyper-realistic details. So if you look carefully, there's so many things hidden in that painting. I've got little cats in the window. I've got an exotic dancer as well, but we can talk about that. And I just loved focusing on details. But with Parkinson's, I could no longer do it. And I had started a big giant canvas, and I looked at it for 2 years, and it got me depressed. So I stopped painting. Well, I then started playing with my food, and I came up with a new style of art. So we can move the slide forward. And that's my food art series, and that's Deli Dawn. So, but the diagnostic, it really shook me up, and it ripped me apart. It felt like someone punched me in the gut when I was diagnosed with this disease. And alone with the neurologist, and my husband came to pick me up, and I said, "Get me out of here." And once we were alone, I broke down and cried because I had to rewrite my future, and it was terrible. It took me a long, long time to accept this diagnosis. And I finally made sense out of it by deciding I'm not my disease. I'm a person with Parkinson's, and I'm going to live my life fully. I got very angry at the disease, and I decided right then and there, I'm going to make PD my bitch. And that's what I've been doing ever since. Now, my neurologist said that he could tell I had PD. PD is a short form for Parkinson's. By the way I walked. So I said, "What do you mean?" He goes, "Well, you're not moving your right arm when you walk. And you're slow. And you're dragging your right foot a little bit." I also didn't have a lot of on my face. So got me thinking, maybe if I did some research, I could override these symptoms. to that book. There's a chapter in it called A Man Who Walked Off His Parkinsonian Symptoms. And I studied that, and he ended up showing slowing down how to walk, speeding it up. I thought, maybe we can move to the next slide. And this is me doing mime, the mime walk. If you can play, yeah, that's good. So I to teach myself how to fake walk normally. Because as a mime artist, I'm always being different people. Like I almost got arrested by police when I used to do street theater. So I figured I can fake walking. And it worked for me. What I started with was imagery. So imagine there's a coat hanger right here, and I swallowed it in my mind's eye, not really. So and once I did that, I had to put my shoulders normal. Otherwise, that coat hanger would be really hurting me. And I also worked with the image of a marionette wire, like this. So what I would imagine was I had the marionette wire at the back of my head pulling me up, and that helped me stand tall. And to move my right arm, I also had a marionette wire on that. So this would help me walk normally. And for my foot, I would focus on feeling when my heel touched the ground, because my big toe wants to drag. Now, I've had PD officially for 5 years. I'm sure I've had it for many years before, as I had a lot of symptoms. But when I go into a neurologist's office today, it doesn't look like I have PD. So there must be something there. And in fact, there is. The University of Guelph has gathered around, and we have 3 wonderful professors who are working with me on some research. And that's Dr. Lorianne Vallis, Dr. Rebecca Barnstaple, and Dr. Kimberly Francis, and of course our wonderful students. So we can go to the next slide, and you'll see my students. Oh, back, no, back, one more back up. Yes, and they're walking around with peacock feathers. And what we found was we play with the brain. And we had people with Parkinson's working with me and training my students. And what happens is people have to focus on the colorful feather at the top. They have to balance the feather and walk across the room. If they're unable to walk, that's okay. They have to balance it. And everybody, we haven't seen it not happen, but everybody's hand stops shaking. So the tremor stops. So there's something going on with the new pathway, I think, in the brain. But we're doing more research with thanks to PSSO, Parkinson's Society, Southwestern Ontario, who helped support the earlier research study we did. And the next slide, if you can move that forward, I'm just going to grab my water here. We have the 400 level group of students. Then I trained the 300 level, they trained the 400 level. We've been working in the community with people with PD and getting great results. We're very fortunate. Now, I'm looking Okay, we've got another adventure. Parkinson Canada has given me a grant, and I've been very fortunate because I'm making videos, self-study therapeutic videos, so people all over the world can apply that and teach themselves how to move normally through the mind. And it's important for me to help with research. So if we move to the next slide, you'll see me being part of a research study. And I'm on so many studies. In fact, I'm now part of an advisory committee with COPEN, Canadian Open Parkinson Network. And they link research projects with people with Parkinson all across Canada. And outside, I have some handouts available for you. I'm going to ask if we can zip to the next slide. Here's another project. I like doing projects because it keeps life fun. So I decided Parkinson's is so hard for explaining. When I tell people I have PD, they often stop seeing me as a person, and I feel them looking at me like a checklist of symptoms. So I decided to illustrate what I feel like. And if we go to the next slide, and I always feel as if PD's trying to take me down, like a wave come up from behind me and put me to sleep, kick me under the carpet, and just roll to a corner with dust bunnies. So I started to open this question to people all over the world. So we go to the next slide. You'll see this man, and Dave in Yorkshire said, it's like living life in slow motion with Parkinson's. And he looks for beauty, small joys, including colorful socks, because he says the hardest part of his day is putting his socks on. So he looks for beauty. If we can go to the next slide, I think there's, what's happening now, which is really a problem. We have more and more people getting PD. I believe it's with pollutants and more young people. So Caitlin Nudge, who's she's in Guelph as well. She got PD at age 31. And she says it's like being a werewolf. It affects her around her hormones. So around her period comes, she suddenly feels okay again. So there's more research that's starting to look at women in PD. And the next slide is a man walking through wet cement. That's how often it feels like when the PD is dragging your feet. And the next one shows a woman whose body is tied up and all in pain and knots. That's a lot of dystonia with the muscle spasms. It's pretty bad. So with the photos, these drawings, I should say, that I created in the book, What Parkinson's Feels Like, it's helping clinicians. So there's one physiotherapist who said to me, I showed a client of mine your book. And it was great because it helped him to communicate more effectively with me what his needs are. Because prior to that, it was difficult to hear him. And I just couldn't understand what was the problem. So this helped bridge that gap. Now, if we go to the next slide, and we've got, there's a QR code that's also outside. If you want to download a free copy, there's a free ebook. We do ask for donations for charities if you can. And we also now have the paperback version through Amazon. And we've already raised through that because all the profits are donated to PD charities, almost $5,000. And it's only been out for about a month. So that makes me happy. And to wrap up, I do want to mention that PD is a progressive disease. And I'm hopeful I'm going to be okay as long as I can because I keep getting mad at this disease and getting out there and kicking butt and living life fully. But it did make me get serious. And I want to read, if it's okay, take a minute to share my philosophy on life. Parkinson's reminds me how precious life is. And I'm aware of my diminishing time and energy to get things done. So I got rid of negative people in my life. And instead, I focus on today and what I can leave behind. And if I hear good music playing, you can be sure I'll be dancing to it. Parkinson's can't stop me from dancing. And then I put that on a little dance clip, and here it is. And that went viral. Last I saw, it was almost 23,000 views on Twitter. And then we ended up, that was even better. I mean, going viral is fun. But what was moving to me is that people instinctively all over the globe filmed themselves dancing. And they wrote with that, they typed, Parkinson's can't stop me from dancing. And some swore, Parkinson's can't me from dancing. And that just really made me feel happy that we can get out and live despite this dang disease. The rest I'll have to say swear it privately or in Hungarian. Now, some great news. I recently saw my neurologist for my biannual checkup, and she gave me great news. Your disease has not progressed in over 2.5 years. So it makes me wonder, maybe being involved in meaningful work and using the arts can really help keep this dang disease at bay and make life happy. So thank you very much. Thank you.
Thanks. So welcome again to our panelists. Discussion. So perhaps, Dale, I could ask you to kick us off. What was it that got you interested in research in the field of neurodegeneration? And perhaps you can tell us more about the research that you're doing.
Yeah, thanks. So I'll start off maybe a little bit with what my lab works on. So we work kind of broadly speaking neurodegeneration, and we focus primarily on two diseases called Huntington disease and ALS, or amyotrophic lateral sclerosis. And so by studying these two diseases that have kind of very different causes, we're hoping to find potentially therapeutics, or to basically find what's going wrong in the diseases and what might actually overlap, to potentially find therapeutics that we can apply to multiple diseases and for these diseases in general. And so one of the things we focus on is the first thing that happens in almost all neurodegenerative diseases. So regardless of the cause of the neurodegeneration, what we see is that proteins mislocalize. And so proteins are basically, they are the molecules within the cells that drive everything: communication, the architecture, the shape of the cell, what have you, or even the survival of the cell. And so this is the first thing that happens. And so we are working on trying to identify why proteins mislocalize. So you can think of that basically like your car that's supposed to be in the garage parked in the kitchen. We need to figure out, one, how did it get there? How do we get it out of there without causing any kind of damage? And we hope by targeting this early event that's in all neurodegenerative diseases, we can potentially find a target. But that opens up kind of another challenge. So we have some therapeutics that we're trying to study, but how do we get them into the brain? And so what our brains have what's called the blood-brain barrier. And in that case, it's to protect our brains from things we don't want in there. But sometimes that also includes trying to get drugs. So one of the projects in the lab as well is trying to come up with a vehicle, or a Trojan horse, so to speak, to get into the brain. And so this is where our two diseases kind of overlap, is when I studied Huntington disease, I came up with a nanoparticle, essentially, that could deliver therapeutics from the blood and into the brain. And so now we're taking that same approach to basically have a genetic therapy for ALS and similar diseases. So that's kind of what we're working on. Do you want me to answer that?
Yeah, maybe I'll move to Travis to introduce and then come back. Thanks, Dale. Fascinating. Travis, would you like to tell us about your research?
Yeah, so can everyone hear me okay, first of all? Yeah, good. All right, okay. So I kind of fell into working in neurodegenerative diseases and health science kind of backwards. I started in physics, so I was studying subatomic physics and electromagnetism, and I started to become involved with trying to understand how life works from a basic standpoint. So big questions, trying to figure out how to describe living processes and how energy moves through these systems. And so I finished up my undergraduate degree at the University of Guelph, and then decided to move out to the University of Alberta and study physics at the quantum level. specifically looking at how we could study proteins and how energy moves through proteins, just to see how life could possibly function. The structure that we looked at turned out to be essential to all life, but it forms unique structures in the brain. And particularly in neurodegenerative diseases, these protein structures, they fall apart. And so because of that, because it was my interest and that's what I started looking at, we started to study, one, what was the process that was driving this protein structure to fall apart? And then how could we control and manipulate that? And then that eventually would turn into looking for treatments for neurodegenerative diseases, looking for new diagnostics and so forth.
Fascinating. So actually both research efforts are focused on these kind of precursors to neurodegeneration, how they can be altered and reversed. So I guess it's a tough question, but what's causing those changes? Do you have, it's the $1 million question obviously, but do you have some initial insights or theories as to what might be happening? Dale?
Well, so that's kind of the thing, at least why we focus on, like I said, because there's a genetic factor, or this is why I say we study these early events, is because there's also genetic factors and there's environmental factors that Barbara mentioned. And then sometimes there's a combination of both, and sometimes it's just actually unknown. And so we don't have an exact answer of like why things are going wrong necessarily, I guess, but there's commonalities that I guess we can try to look for. This kind of answers your question.
You sort of made this interesting point that studying one particular type of neurodegeneration might provide insights into a broader range of diseases. And is that because there might be some fundamental mechanisms that underlie each of those different conditions?
Yeah, exactly. Yeah, so exactly. So the other thing besides like really mislocalization, another characteristic of a lot of neurodegenerative diseases is that proteins will aggregate. So they basically glom up to each other. And that's another indicator that basically there's something going wrong with the cells, that there's not a proper turnover. So that's another way to target things. But I'm going to lead into basically Travis and feed him a question, but another kind of commonality that we see in a lot of neurodegenerative diseases is inflammation as well. And so there's a lot of ways that can be that can contribute to inflammation, like stress that Barbara was mentioning, or environmental factors. But I think that leads nicely into what Travis does.
Yeah. So going along with my story here. So after I finished my PhD looking at small stuff, I took a faculty position and started looking at very large things, so looking at how the brain functions in general. And the institute that I worked at was primarily focused on neuroinflammation. And so I learned a lot of biology at that point, got me up to speed on biology, to be honest, but learned how important inflammation was as a process, throughout the entire body, but specifically in the brain. So the brain has its own unique immune system, and it responds to insults. So stress, environmental toxins, problems with genetic malfunctions. It can trigger an inflammatory response. And it seems to be that this inflammation, or low-grade chronic inflammation, drives a lot of brain pathology. So you look at anything that goes wrong with the brain, almost always it's inflammation to start with. So mental health disorders, unexplained complex chronic illnesses like long COVID, things like neurodegeneration, Alzheimer's, Parkinson's, ALS, they all have this common factor that there's a increase in inflammation. And so that's kind of where I've taken my tact, is not only looking at these protein structures, but how it's attacked by inflammatory mediators, things like stress, oxidative stress, other triggers that can cause damages in the proteins, which can then lead to these things that Dale's been talking about, mislocalization of proteins clumping up and forming what is known as the hallmarks of these diseases. So things like Alzheimer's and Parkinson's, and I think Huntington's and ALS also have their own unique protein aggregates that are unique specifically to each of those diseases. But down below that, I believe, is the inflammation.
Fascinating. And Travis, kind of on that same point, looking at these things from a large and from a small level, can you tell us a bit more about the quantum nature of your research? What is quantum biology, and what is quantum, and how does it connect into answering these questions? Okay,
so I'm not sure what anyone knows here, but so there's standard physics that describes kind of how things work in the world. And if you look at how that's described, it's kind of like billiard balls banging around. And we have these amazing descriptions of how to describe the world that we see around us. But the smaller you get down, so you go from cells down inside of cells to organelle structures, and then you go down to what those are made up, and they're made up of proteins and fats and whatnot, and you go smaller than that, you're getting up to small molecules. And when you get to that range, to small molecules down to individual atoms or ions, things start to behave a little bit differently. So they don't necessarily behave like billiard balls. They behave more wave-like in some instances, or particle-like in another instance. And it's described by a different set of physics, which is called quantum physics. And so what we're doing is we're looking at these processes that are involved in inflammation. So, for example, things like there's certain molecules of oxygen that can be quite damaging because they need electrons. They steal electrons in a system. And the only way to describe that down at that level is to appeal to a quantum description, to get an accurate description of how do these molecules go and steal electrons from proteins, and where does the damage end up. And so that's basically what we're doing, is trying to describe that process in detail so that once we know how it works, we can figure out ways to stop it from working.
Fascinating. So right in the quantum realm,
Right. Yeah.
tying into the brain. Wonderful. Well, I guess going from the quantum realm to the whole body, Barbara, I wonder if I could ask a question for you. Thank you again for the fantastic presentation. And other than medication, diet, and exercise that you've described to us, what else have you found that's been helpful in managing your disease?
I find it helps to have a good social support group. And I'm fortunate I have a wonderful care partner husband. And also the other thing is attitude. Like I mentioned, I got really mad at this disease, and I had been progressing. The disease was spreading. And then I decided that let me focus on what I can leave behind. And then I made it my mission to focus on helping my PD brothers and sisters all over the world. That's what drives me. And to do that, I have to have a balanced life. And sometimes that means saying no, boundaries, rest. But I like to laugh. So I was telling Travis some dirty jokes before we arrived here. So, and I love art. I've been drawing your portraits here. I haven't got to you yet, Dale. So I just love life, embrace it, live it, and make it good. I try to put smiles on everybody's faces as I move through my day. I often joke with the cashiers, and I see someone with a cell phone. I say, that's a prop. You're just using that to get me, baby. Or, yeah, I shouldn't say that in front of my husband. Sorry.
And Barbara, I guess one other part of this is being able to access the care that you need at the time that you need it. And
yeah.
I wonder if you could comment on your experiences in advocating for your own care and what you've learned through that process.
It's tricky. I can share what I do because everybody's different and everybody's comfort level is different. But when I got to be a certain age, I stopped caring so much if people approved of me or liked me, because there's no way I'm going to be able to make everybody happy. So I know what is right, and I know when things are bad and wrong, and I speak out. And I also find a way so that I'd be heard, because you can speak out and tune people out with the music. It's like your music. Oh, someone leaves the room and you go, even though they said all the right things, I'm left feeling, I don't like them. I don't want to hang with them. So try to focus on where we have something common, that we're all humans, and bring joy. I like to chat people up, but I also do my homework. And I find out what's important to that stakeholder and see how we can grow my goal together with their goal. And if you find common ground and you be kind, it can go a long way to making things happen for advocacy. So
Thank you, Barbara. That's fantastic.
yeah.
Thinking of motivations for the things we do, Dale, maybe you could tell us a bit more about why you chose this area of research. What drew you to it? And
So what got me into neurodegeneration? I mean, to be fair, I always tell students about this because like I was always interested in neurodegeneration and neuroscience, but I actually didn't think I was smart enough. And so it wasn't until I was in grad school and a project kind of fell into my lap that was on Huntington's disease. And after that, I got really involved in Huntington's disease and working in a lab that that lab itself was also incredibly inspiring. Because before I had worked in areas where it was, it was patient adjacent or disease adjacent, I guess. But then we were in this lab where everybody just did totally different research. But there was also genetic counselors. Students were becoming genetic counselors. There's geneticists, biochemists, what have you. And then we were also interacting with patients a lot more. And so it was once we started interacting with patients and having them come into the lab and meeting them and understanding them and understanding their needs, the passion kind of changed from just being curious about science to being like, I could really have an impact on somebody's life. And it's not an abstract thing anymore. And so once I got my own lab, I mean, that's incredibly inspiring. And then I'm fortunate, and they're actually here. I'm going to point them out. But I have some students that are from my lab, a couple of alumni too. And so seeing their excitement and seeing their journey. And then, I have an undergrad student that just completed a drug screen for what we're going to try to put into like ALS. And another student who has another drug we're trying to get into Huntington's disease. So we have it in preclinical trials just starting 2 weeks ago. So anyway, so these are the things that drive me. Sorry, I'll just keep going if I don't stop now.
That's great to see your passion. I guess just on your final point there, what is the pathway for lab-based basic research in this area through to a clinical trial? How do you, what's the pathway for translation and what kind of timeframes are involved? Maybe you could describe a little bit more about that process.
Yeah, I guess the timeframes are not obviously, but they can be very long, right? Because sometimes it's just a finding on a bench, and then you've got to get that into a preclinical model, which is usually some sort of animal model. From there, if it's successful, right, then it has to go into clinical trials. And clinical trials, it starts off with small groups of people just to make sure it's safe, and then you need phase 1, phase 2, phase 3, and then typically phase 3 is multiple patients around the world, multiple clinical trials going on, and then that's where a lot of things kind of fall through. So yeah, we try to look for accelerated things. Like right now, we're trying to repurpose FDA-approved drugs, try to find things that a new purpose for a drug that wasn't expected. And I was just at the International ALS meeting in Montreal a couple months ago, and I was really surprised. One of the clinical trials that was really had gotten pretty far and is in phase 2 clinical trials with patients. It was antibiotics. It was a combination of 2 antibiotics, and it was having, at least from that panel that I went to, it had the greatest effect. So I guess the point just being sometimes you just don't know where some of these drugs might come from, and again, it can kind of advance the drugs to patients.
Yeah, interesting. Thanks, Dale. And Travis, for your research as it stands now, is it a similar pathway to Dale's for translation in the longer term?
Yeah, well, it's somewhat. It depends what aspect we're taking on it. So we have we've looked at the traditional drug discovery route as well, and tried to counteract certain processes that are of interest and that show promise. And same thing, you test the drug. If it's a new drug, it's got to go through a much longer process because you have to check out safety, preclinical models, show efficacy in cells and then animals and so forth. And that's a long journey. It's faster if it's a repurposed drug or a drug that has it's already gone through those steps of safety. But we're also looking at different ways of intervention. So one thing that we should promise with is manipulating, we're manipulating protein structures with magnetic fields. And so trying to manipulate the protein structures I was talking about earlier that disintegrate in neurodegeneration, our work has shown that magnetic fields can stabilize them. And right now it's just in a biochemical assay. Next step is to move it into cells. After that, we're looking to see what the avenues are, because it's not not a drug, so I'm not sure how the safety profile goes. And it's not like an NMR machine where it's a very strong magnetic field either. It's more localized and controlled. We're also looking at similar avenues with light, and then the combination of light, magnetic fields, and drugs somehow working together to elicit a new approach.
Fascinating. So this would be like projecting through to the clinical trials. This would be
Correct,
a magnetic field applied to the...
Yeah, so magnetic field, they already use things like TMS, which is transcranial magnetic stimulation. And those are very, very high magnetic fields. And so because those have already made it through the steps of FDA approval and clearance, similar to a repurposed drug, we would just be doing something similar, but it would be weaker, so more likely to pass, and more localized. So what's the first of the question?
I think that was it, but
yeah.
This is something that would be applied to somebody's head.
Yeah. I don't remember what the other thing was. And then other groups, not particularly ours, but another area we're looking at is it's called photobiomodulation, and so it's applying light to the brain through the scalp, and it's showing some promise. The mechanisms aren't quite understood, and so that's part of the work that we're doing, is trying to figure out what is it that is causing the effects that we see. So people are applying lights to the head. They're seeing promise in treating things like mental health illnesses and reducing inflammation. But why? We're not quite sure. If we can figure out what that mechanism is and then optimize it or exploit it, we could potentially start treating things that have a stronger impact, maybe like ALS or Parkinson's or Alzheimer's disease.
Fascinating. Yeah. As a bit of a segue, in my research, I'm interested in neurodegeneration in the retina and how we can induce neuroplasticity in the brain to help people relearn how to use their remaining vision. And as part of that, we use TMS and magnetic fields to induce neuroplasticity in visual areas of the brain to retrain them. And one of the questions we're asking now is how we can take that into the clinic, so people could use it at home, or they can use it in a regular optometry clinical environment. So it's interesting. We should talk more about that later.
We have a mechanism. Anyway, we'll talk.
Yeah. One thing in terms of kind of translating treatments into the real world is, how do you measure whether somebody's improving their condition? And I wonder, Barbara, I know that you're involved in many research studies and you're connected into research yourself.
Yeah.
What kind of outcome measures are you interested in, and are other people interested in assessing whether different types of interventions are effective?
Can you repeat that? I'm sorry.
Oh, sorry. Yeah. What should we be measuring to test whether a drug or another type of intervention, say for Parkinson's disease, is effective? What are the kind of outcome measures we should be thinking about?
Well, there's so many, right? So it could be small things like speech, how you even write a letter that we can see your handwriting. So there's so many areas. For me personally, it comes down to quality of day-to-day life, so that that people can be as independent as possible and communicate. And I'm thinking not just Parkinson's disease. I volunteered a lot, and I volunteered with a family where one of the parents had ALS. And it was for them all about quality of life and joy. So I found in my working with this family, and you might know the name Margie Johnson. She was the person with ALS, and they gave me permission to share their story. She was able to type or communicate with her eyes with a machine, and they were saying that opened up the world to this family. So things with communication, so that you can get your ideas and thoughts and wants out there, that's so important. Being independent, nobody wants to be a pain to somebody else. That's one of the things that scares me the most, is where I lose all my ability to do things for myself. Then what sort of life is that? So any help with those areas would go a long way. But better yet, a cure. I'm holding out for a cure.
On that note, Dan and Travis, what do you think is the next big breakthrough that's coming in your field? What are we really kind of waiting for to move research onto the next stage in this area? Travis, would you like to go first?
So in quantum biology, the big thing right now is we have a lot of theories, and we've been able to figure out how these things work at a physical level. We can test it in a cell, or not a cell. No, that's the next step. We can test it out in a biochemical assay. And right now, it's if we can show proof that we can then do it at the cell level, I think that's when we're going to hit the ground running. So once you can show that these small effects, which we can easily manipulate in an isolated system, if we can start to do it in a cell level, that's going to be our biggest next step.
Is that close, do you think?
Yeah. I mean, like I was mentioning before with the magnetic fields, we've shown this effect, and we're trying to gear up to do it in cell culture. And I think that's our next big thing. We're seeking funding for that, and fingers crossed, we'll have some very soon, and we'll have some results shortly after that.
Exciting, thank you. Dale.
Yeah, I mean, so it's a very big question, and it kind of relates to your question about the timing as well. But so one of the big things I think in neurodegeneration, or particularly for genetic diseases as well, are antisense oligonucleotides. And these are just basically small DNA molecules that can kind of just turn the gene off. I'm kind of oversimplifying it, but that's basically what it is. And what it was, this is a technology that came out in the 80s, and everybody said it was never going to do anything. And one small group stuck to it, and they worked on the biochemistry of it, and they made it safer and safer. And then now, it's a very effective treatment for spinal muscular atrophy. And then now it is probably one of the biggest. There's multiple different clinical trials in Huntington disease and then ALS as well. So there was one that was just approved for clinical trials for a type of ALS. So there's these antisense oligonucleotides, but again, it goes back to that whole like how long can it take? Sometimes it's just working on that basic biology first and getting it down, and then we can apply it. So I think that's one of the big things. There's a whole bunch of other really amazing things. And I do want to say like one thing, because this is I want to make sure that I have an opportunity to say it, because the reason right now that I think one of the exciting things about Huntington's disease, ALS, or for the research I should say, is there's so many clinical trials going on right now, and a lot of that has to do with the patients, obviously, because not only obviously we need patients to be involved in the clinical trials, but it's also they're donating their cells, their tissues, their time, their everything. And so like now we're at a stage where there's so many options going into clinical trials right now that it's really exciting. And again, like a lot of it has to do with the patients themselves.
Thanks, Dale. Lots of exciting breakthroughs on the horizon. Fantastic. I think at this stage we'll open it up to questions from the audience. So I don't know whether we have any questions through the app, or if anyone does have a question, do feel free to raise your hand, and we have microphones that can come around so that we can hear you. Yeah.
What does therapeutics refer to? Is that a treatment type? What does it entail?
So the question is, what does therapeutics refer to? Is it a treatment type? And what does it entail? Therapeutics. Dale?
Okay. I mean, yeah, so a therapeutic would be, I guess, any kind of thing that could be a disease modifying, or something that's making or correcting the symptoms of the disease or treating the disease, right? So that can be many different things. So it could be pain treatment, like when we think of like aspirin, Tylenol, that kind of thing. But in terms of neurodegenerative diseases, we're talking about like trying to ultimately cure the disease. That's the ultimate goal. But as I think Barbara highlighted really well too, it's also increasing or making the quality of life better. And sometimes that's honestly the best, not the best we can do, but like that's the best pathway, is sometimes just making their lives better, right? I think that.
I just want to add to that. Traditionally, particularly in my field, we think of therapeutics as drug, magnetic fields, light, whatever. This intervention that you have to do, and that's kind of what people generally think of when you think of therapeutics. But what Barbara was talking about earlier is changes in lifestyle, reducing stress. These are all therapeutics as well, particularly as all of these things that you did mention are things that can drive neuroinflammation. And if you can reduce that in any way, it's a therapy. It's helpful in some regard.
Thank you, Travis. Any other questions? Yeah, we have a question here. I'll also just say, whilst the microphone's coming around, we have our door prize draw happening shortly. So do
so I know, oh my God. Barbara mentioned earlier the importance of maintaining quality of life in like patients with, say, Parkinson's or other neurodegenerative diseases, but also like that she'd really like a cure. So how do you guys balance looking at treatment options and quality of life improvements versus like trying to find a cure to a disease?
Could you just repeat the last part?
Could you repeat the last part of the question?
How do you guys balance how do you balance looking for like improvements to quality of life and like treatments versus looking for a cure? And what do you think is like more important to focus on?
Maybe I can give an example from the area that I'm involved in vision rehabilitation. When we think about people with glaucoma, where you lose your side vision, so you develop tunnel vision over time. One of the big questions is, what should you be measuring to know whether drugs are working or not? So one of the measures that you do in the clinic is a visual field. So you flash little dots of light and you see whether people can detect them or not in different areas. But people with glaucoma are not really interested in how well they perform on that test. They want to know how well they can navigate in a real world environment, how they're going to manage in a supermarket, whether they can continue to drive and to read. And so I think it's a really important question. How do you design your clinical trials? Should you be looking at these very specific, well-controlled outcomes, or should you be looking at some real-world measures, which of course are much harder to quantify in a way where you can detect a drug effect or another intervention effect? It's a debate that's going on in the field, and I think a lot of trials are now trying to combine the very well-controlled outcome measures with some real-world measures as well, some of them just being broad, like quality of life measures as some of their secondary outcomes. That's certainly in vision rehabilitation. I don't know if something similar is happening in brain neurodegeneration.
I can comment on when I was working in complex chronic illnesses with a neuroinflammatory component. So it's not quite ALS or Parkinson's, but these are illnesses that stem from neuroinflammation and wreak havoc on your life. So things like myalgic encephalomyelitis, chronic fatigue syndrome, Gulf War illness, which is exposure to a low-grade chemical agent during wartime, and more recently, what everyone is probably familiar with, but post-COVID syndrome. And so in these cases, whenever we would do trials, the primary outcome variable was always quality of life, mainly because we didn't have a distinct measure in biology to measure against. So we didn't have a mechanism, we didn't have a thing that we were trying to fix at a molecular level or at a brain scan level. We didn't have that. So that was really our only measure. Whereas something like Alzheimer's or Parkinson's, there are hallmarks that we can look at. So we know there's neurodegeneration, and we can see brain cells dying, or we can see plaques or tangles or whatnot. And so depending on the trials, depending on usually the modality that's being employed, they will look at different things. I would advocate that both things should be looked at, because if you think there's a mechanism and that is what's driving the problem, and you have a drug or a treatment that's to break up a plaque, you want to make sure it's doing that. So for example, if I have a drug and I say it's going to break up this plaque, and I give it to somebody and it doesn't, but everybody that takes it improves their quality of life and the reduced tremors and whatnot, do we care that it didn't break up the plaque? No. So there should always be two aspects to a study. If there is a biomarker or a biological thing you can measure which you think is causing the illness, measure that, but also measure these other things. At least that's what I would advocate for.
Yeah, I don't know if I have too much to add to that, other than I think the ultimate goal sometimes in the lab is cure, but like Travis was saying, if it's just doing something that's making somebody's life better, that's just as good, right? And we're just happy to have that. But then I think again, it's interacting with patients that I've learned a lot where again, the goal was always the cure, and then it's like actually increasing quality of life could be just as important. So actually, there was a really good example. I used to work in the spinal cord repair area of research. And same thing, trying to make people walk again. And then met with some patients. They're like, "What do you want?" And he's like, the guy just said, like, I'd like to go to the washroom on my own. I just want a little bit of independence. That's all I want. So it's just like the needs are totally different than what we're trying to get to, I guess, sometimes.
Yeah. Well, I'm not a scientist, but I'm fascinated by the work that you are all doing here. And I first I want to say something to the audience, because you people mean so much to me. And I am so grateful that you're here tonight, because you give me hope. And not just for a cure, and I know we will find a cure. I believe we will. But the quality of life has improving for so many people with neurological diseases because of you. And maybe I'm a nut, maybe I'm just a dreamer, but I think trying stuff that people think maybe has no chance, like doing the mime, I was laughed at. I was not taken seriously until I showed it worked with myself. And then I checked out other studies. So I'll just give you one short anecdote. It was studying facial paralysis. In Parkinson's disease, sometimes we get what's called hypomema. I think that's it, where the face just freezes. So no one knows what you're feeling. And they used mime. There was a study done, and they helped wake the faces up, bringing people back to life. And the ones who had the most success were the ones early on in the paralysis. So they lost some facial paralysis, maybe half the side of the face. And it woke it up, and it lasted. So that gives hope. I still believe there's going to be a cure, and I think it's around stem cell research. That's my gut. Because I did a PD gene study, and they found I don't have the 7 hereditary markers. I got this dang disease. All right, I'll say it for what it really is, this disease. There, I said it. Mom suddenly came to mind, so I had to, sort of mask it a bit. Because I was once originally healthy, and my stem cell has been taken. I'm hopeful they're going to get the go ahead to put it back into me, and maybe they can recalibrate my brain so that I am normal and healthy again. Wouldn't that be wonderful? I love dreaming. And then put it into action somehow, some way, with people like you, wonderful people. You are the ones I'm here for, because I want to say thank you. You give me hope. Thanks.
Thank you, Barbara. We have
Mention of a protein that is necessary for all life. Aren't all proteins necessary for life?
So just to restate that, there was the mention of a protein that was necessary for life, and the question is, aren't all proteins necessary for life?
Yeah, so that was me. That was a misspeak. Thank you. Well, I was referring to a protein that is found in all eukaryotic life. It's an essential protein. Of course, all proteins that are involved in life are essential to that organism, but it's not all proteins in one organism are found in another organism. So the one I was talking about was found across life. That's what I was referring to. Thank you.
Thank you so much. Really interesting talk, like just panel discussion, and it's really enlightening to know about your real life and how you amazingly healed your body. At least it hasn't changed for the 2.5 years, and I hope that stays the way and you can heal it furthermore. What I was thinking was right brain kind of a situation also, that the creative angle, because she could tap into it, and that kind of led to further neural plasticity. And those are the changes that can be further tapped into, like say if we're using TMS, and like if some further ahead and developed into the far stages, so maybe using those kind of technologies will also help them to perhaps rebuild those connections and get them back.
Yes, I guess I can answer the first part of that question. So certainly there are emerging technologies like TMS and also deep brain stimulation, where electrodes are implanted into the brain, that have shown some quite dramatic changes in certain symptoms in certain neurodegenerative diseases. I think it's been touched on across the panel as well. One of the limiting factors for developing these treatments is we still have yet to learn how the brain works in terms of how these different networks are interconnected. And so it's important that we continue our basic science and also the implied science as well, so we can kind of triangulate how we use these new technologies optimally to recover function in people with neurodegeneration. But you're right, this is definitely an emerging area. I don't know if anyone else has comments on that. I guess, Travis, you're also thinking of these kind of neuromodulatory types of technologies.
Yeah. So I don't think I quite heard the question, but I agree with what you were saying.
That's always a good answer. Thank you very much. Dale, anything?
No, I the same kind of situation. I think we have to be open to like that. There might be a lot of different things that work for different people and different diseases. So I that's not necessarily my area, but I think being open to these ideas helps a lot. Also, I think being at a place like Waterloo, where we're not necessarily confined to thinking one way, I guess, because of med school or something like that. I feel like we're maybe a little bit more open to that kind of thing. I don't know.
I will say this, that I don't think, maybe one day that there's one specific thing that you can do. You do this one thing and your Parkinson's disease will go away. But until we get to that point, I think combining things like, for example, movement or mime, or continuing these things in addition to lifestyle changes, in addition to magnetic field therapy once a week, to keep driving this thing in the right direction, slow down the progression and eventually turn it around. I think combination treatments or treatment modalities is the way to go.
Well, I look at it anywhere, anything, and collaborating, and also maybe something that you might discover works for one disease. Perhaps it could also impact another neurological disease. So I think there's something we can gain by sharing knowledge and working together and being open to crazy, wild ideas, like the woman, Joy, I forgot her last name, who can smell Parkinson's. And she was laughed at and hid her gift because it was looked down on. And now science has proven that is a wonderful tool, and it can help diagnose things much faster.
Fantastic, thank you. Well, I think that we are now out of time, but I think just one comment, actually, Barbara, to you. Oh, one more question, sorry, please go ahead.
So through my role, I work with people who have Parkinson's, with the Parkinson's Society, and I run a lot of support groups. And unfortunately, people who I work with, they Google a cure for Parkinson's. They're very hungry for information. And what I have found is that there are plenty of businesses that claim to have a cure and will just, like, people will pour money into things. And I can't tell people what to do and what not to do, but I can just say, I will do my best to find an answer for you. And recently I've been getting a lot of questions about stem cell transplants. And there's a business that must sponsor ads on Google because they come up a lot, and that will promise to do stem cell transplants, and they are expensive, but have stated promising information about slowing the progression of Parkinson's disease. Are you able to comment on that? Is there any truth to that, or is it a scam?
I can't comment on. I'm not. I know what you're kind of talking about, but I can't comment on whether that is a scam or not. I'm not specific with that. I will say in my area, if you type up quantum and health, you're going to get a lot of stuff out there where people are saying, we can heal you. We've discovered the way that life works, and if you send us $59.99, that we have the answer for you for any problem that's out there. And that, I can tell you, is not true. So I think in any field that you're going to get that, especially in the information age that we live in. And, the tried and true thing is, listen to your doctor, for one. They're not, I don't think for the most part, they're trying to steer you down the wrong path. There is going to be new and exciting treatments coming out, but the medical community is going to be the ones that are the fast followers of that. So if something works, they're going to put it into practice. At least that's what I believe.
Yeah, they're not going to be trying to profit from you. So that's kind of your first sign, I think. If I could just kind of build on that, because I think you mentioned the PSSO, Parkinson's Society of Southern Ontario, Southwestern Ontario. But I mean, that's these nonprofits are really great resources for patients to go to. And so I'm going to use that to plug Huntington Society of Canada are here today. They're founded here in Waterloo. And then also ALS Canada, there's Colleen's here, and so Alexander from HSC. And then on top of you can talk to them. You can go to the websites, and they'll also give you some of this stuff. And sometimes there'll be even blurbs about these kinds of things as well, which are also helpful. At least for Huntington's disease, there's HD Buzz, where they literally will break down all this kind of stuff in lay format for patients, so that patients are really, really well informed. But anyway, my point being is just that these societies, they're a great resource. They fund our research, but they also take care of patients and their caregivers and everything, and then they provide that information. If you have those kinds of doubts, maybe reach out to one of these societies and they'll help you out.
Can I add something? One thing I don't regularly let people know, but one of the reasons why I'm so outspoken and dedicated as being an advocate is because I had a terrible start to when I was diagnosed. The neurologist was sort of like a godlike concept. So I can save you. I am the one. And I was regularly pressured by this person to rate him on ratemymd.com as he wanted to be the #1 neurologist in the world. And by being put on a lot of brain medications, I became, okay, whatever you say, I don't know. But after I woke up and I no longer am with that person. In fact, that person's no longer practicing medicine. It made me realize you have to use your gut, your brain, your feelings, all of yourself as the patient. And don't just take things because they say they can heal you. Question everything. And go to good sources like PSSO, like Michael J. Fox Foundation, Davis Finney, and use your noggin, all right? So someone says, I can cure you. I always go, yeah, right. Let's check this out thoroughly. So maybe I'm jaded now, but that was my start.
Thanks, everybody. And I think that question really underscores the importance of the science that is going on here at the University of Waterloo, and your work as well, Barbara, to work together with universities to advance our knowledge in this area. And I would say that working here at the University of Waterloo, it really is a uniquely interdisciplinary environment. And you can kind of see that from those of us sitting here on the panel. And I think that this kind of research, hopefully, as we've heard, will continue to drive the field forward in an evidence-based way. So I think on that note, I would like to thank our panelists very much for all of their insights and comments today. It's been a pleasure speaking to you all. And we'll give them a round of applause. Thank you.
Thank you.